Section 1.3, Explore. How far does vehicle B travel after being hit? The purpose of this lesson is for students to understand how to design a consistent procedure. In this section, students will design a procedure to measure the distance vehicle B, our car, travels after being hit by vehicle A, the truck. Students will focus on modeling the collision that happened at the intersection of Park and Main in their laboratory or classroom. First, students will start to look at our maps. Map 3, which is the previous year's accident data, and Map 4, which is this year's accident data. Students may begin to realize that the cars travel different distances after the collision. They might notice that this distance might also tell them something about the severity of those collisions. They want to test this idea using their model. The students will create a model of the intersection, have two vehicles collide, the truck hitting the car, and see if they can measure the distance of vehicle B after the collision. They can get a measure of that distance, they might have a better idea of what factors cause the accidents. Make sure to point out on both maps how the more severe accidents are located in certain groups and the less severe accidents are located in certain groups at certain distances. Students will begin to gather their materials. The materials that students will use will be two Lego vehicles. Students should have built these Lego vehicles prior to the start of Section 1.3. Students will use both Vehicle A, which is a model of a truck, and Vehicle B, which is a model of a car. These are what the built structures of the unloaded truck and car will look like. The truck will be larger and will have the front bumper, and this is a picture of the car. Students will also have a cardboard ramp and a tape measure. Students will start this investigation by designing their procedure. Students will have a free design of their procedure. They will work in their groups. They will discuss how to design it. That will have Vehicle A, which is the truck, travel down the ramp and then measure the distance that Vehicle B travels after being hit by Vehicle A. Students must use all the materials on their list, and each person in the group will write down the procedure on the procedure and data sheet. Students at this point are only writing 3 to 4 steps of their procedure and model that is recreating the accident scene. As soon as the students have written a procedure that demonstrates that a collision is occurring between the truck and the car, Vehicle A is the truck, Vehicle B is the car, and they have a method of measuring the distance that Vehicle B travels after being hit, they may start to complete their investigation. Students should complete their investigation with their materials and record the distance Vehicle B traveled on their procedure and data sheet. Students will be completing 10 trials of this distance and should record in centimeters the distance that Vehicle B traveled. Although this is a free design and students will be deciding on their own procedure, and this should be very low facilitation because this is going to be true inquiry. You really want the students to come up with their own steps. One important factor is you do need to remind students to measure exclusively in centimeters. The reason is that if some students measure in inches and some students measure in centimeters, their actual procedural design might not matter as much because the data will be skewed on their measurement, and we want to focus actual on design, not on their measure. So it's very important that you remind students using the tape measure that they will measure in centimeters. Just to show you some examples of what different setups might look like and what you might see in the classroom, I will show you a couple of pictures and videos. Students will hopefully have their cardboard ramp attached to a ramp holder set up similar to this to have the truck, which is Vehicle A, go down the ramp to hit the car. Students may have the starting edge of the wheels in different positions. Sometimes students may end up pushing the truck down the ramp or just releasing, but overall students should have the truck going down the ramp to hit the car, vehicle B. Students should also then have their tape measure lined up to see how far vehicle B travels. Again, you want to allow students free design, but this is some of the examples that you might see. There might be many inconsistencies between students' setups, and that is okay. For example, one inconsistency might be the position of the car at the end of the cardboard ramp. Some students might line it up exactly at the edge of the ramp with the wheels touching the cardboard so the truck hits it immediately. Other students might leave a space. Some students might have it slightly turned in either direction. So you might see different variations. At this point, you allow students to go through with these variations, as this is part of the learning experience of developing a consistent procedure. Something else that you might see, this is an example of the truck going down and hitting the car. As you can see, and I will replay the video, often once the truck hits the car, it continues to push it. What some students might develop is a method to actually simulate the collision a little bit better, where once it has hit the car, the truck is not just continuing to push it, and it might look something like this, where they stop the truck or pick up the truck prior to it pushing the car. Again, in this section, students can have this free design, but this is something to consider, that it will skew your data versus if the truck is hitting the car consistently, or if students are stopping the truck before it continues to hit the car. After students have completed their investigation, completed their 10 trials, and recorded their data, okay, you will create a class histogram where students will share their data, and it will be graphed on the class histogram. You might need to remind students and review exactly what a histogram is, and that it shows the frequency that a specific outcome occurred. The more accurate and consistent everybody's procedures would be, the more frequent certain data numbers would reveal, or the histogram would reveal a higher frequency for certain data numbers. Each group will share their data, and the teacher and the groups at the same time, students will have the sheet, will be marking on the histogram how many times certain data points have come up. So if a group, and again this is all in centimeters, maybe had 67, they would fill in here. Then if they had a 78, they would fill in right here, and so on until the whole class has shared their data. Then the class as a whole will start to examine the data on the histogram and see how accurate and reliable it was. You might notice that different groups got different data about how far vehicle B traveled after the collision. It's going to be very likely that the class is going to have low frequencies of data points, but have a large range of data points. And this will show that the class as a whole did not possibly follow a consistent procedure. If groups also have low frequency and high variability or high range, it would also show as a group that they are not demonstrating having a consistent procedure. It would be very important to remind students of the definition of consistency, repeated adherence to the same principles, course of action, format, and the idea that completing the procedure in the same way each time would be consistent. This discussion of the histogram will then move into section 1.4. The teacher will need to keep a copy of this histogram because it will be used again in section 1.4.